So I wanted to talk for a second about being lied to and the use of graphs and statistics in order to do that, because people are lying to you with graphs all the time. Believe it or not, if you watch the news, if you're into politics, people are trying to lie to you. They're trying to manipulate you into believing what they want you to believe using their numbers. And so I just want to talk to you for a second about how you can help guard yourself against this kind of manipulation and hopefully come away with a better understanding of what it is that people are trying to do when they are showing you a graph. So whenever you see a graph, whether it's on TV or if you're reading a paper, you have to start by examining it carefully. And part of that is looking at what do the axes actually say. Are the axes clearly labeled? Does it make sense what the axes are saying? The next thing you should look for is there any statistical nonsense happening? Are they log transforming something? Are they putting something on the axes that doesn't make sense or isn't necessarily justifiable? So a lot of times I'll see statistics and things that I don't quite understand, but if someone can't explain it to me, it raises my eyebrows. It doesn't mean that what they're trying to show you is not true, but it potentially means that they could be trying to manipulate something. Are the axes meaningful? Is what they're trying to convey to you actually represented by those axes? Are the graphs intentionally deceptive? And we're going to talk about examples of each of these, but are they trying to screw you up with how they're presenting the things? And then after you've evaluated the graph itself, you have to ask, who has what to gain by showing you this graph? And then finally, how do they generate their data? Or is their sort of experimental approach legitimate, or is it just kind of bogus? So I thought the best way to do this was to actually take a look at some of these graphs. So here is a picture of government spending. You can see it's a flat line from 2016 up until 2019, and then it skyrocketed. But you'll notice the y-axis isn't labeled. And so this graph is almost completely meaningless. I mean, what do these two represent? Did government spending go up by $1? Did it go up by $20 trillion? Like, nobody knows. So again, make sure you're taking a peek at the axes and how they're labeled. Here's another interesting one. So it says here, and Group C is missing because I just messed up, sorry. It says here, Group A is up here at 62, and Group B is way down here at like 54 or something like that. And so the problem with this is that it's kind of zoomed in a way that is seemingly kind of deceptive. Because when you zoom out and look at the entirety of the data, you notice that the difference between these two groups is not actually very large. It's just a few percentages, or a few percentage points, but if you zoom way, way in, it looks like, oh, Group A is certainly very different from Group B. But not really the case, right? They're not in the grand scheme, they're not all that different. And you would need to take a look at what actual data are being presented here. It could be a large difference, but just something to keep your eye on. You see this a lot when they're looking at the differences between political parties. It'll be like, Democrats support this 55%, and Republicans support this 59%. And it's like, well, that's just a 4% difference. It's not. But the graph will be zoomed way in and make it look like it's a huge deal, when in reality, maybe not. So this is a graph doing kind of the opposite. It's showing you the trend in temperatures from the late 1800s until 2010. And the problem with this is that by zooming the graph too far away, it intentionally misleads you into believing that temperatures aren't actually increasing. So if you're looking at average global temperatures, this is an average of the temperature everywhere on the planet increasing by 2 degrees Fahrenheit. It is quite a significant change. Okay, so graphs can be zoomed too far out to be misleading. Graphs can be zoomed too far in to be misleading. You just need to be careful and be thinking about, well, what pattern are they trying to make you see? What do they want you to get from this? Here are some fun ones. So the axes aren't labeled at all, and you'll find out why in just a second, but you'll see here there's a very, very tight correlation between whatever these two quantities are. But again, the next thing you should ask yourself is it meaningful? And this is the number of people who drowned by falling into a pool as correlated with films by Nicolas Cage. And the correlation's very, very good. It's excellent. So again, is it meaningful? The next one is letters in the winning word of Scripps National Spelling Bee versus people who have been killed by venomous spiders. Super tight correlation. Very, very, very close. But obviously, these things don't have much to do with one another. Okay, so that's just some tips for evaluating and looking at data. I'm probably on an exam or a quiz going to show you a graph that is intentionally misleading, and I'll ask you, hey, what's going on with this graph? How can, or I'll say, hey, here's this misleading graph. How would you fix it, or something like that?